Come and have a look at this. This is a Newton spring balance, and it's a device which enables us to measure force. It has a fixed end which is used to support the balance, and a free end which moves. So how does a spring balance measure force? Well, as my hand pulls the free end, it stretches a spring, and in doing so, I can feel the spring applying a restoring force to my hand. In order to maintain the stretch of the spring, I have to apply a force equal and in the opposite direction to the restoring force generated by the spring. As I increase the stretch of the spring, I have to apply a larger force, and as I do so, the spring applies an equal but opposite larger balancing force to my hand. So in a spring balance, there is a relationship between spring extension and applied force, and therefore by measuring spring extension, we can measure applied force. In order to do this, we have to know the precise relationship between spring extension and applied force, and to establish this relationship, we need to conduct an experiment. So as part of our experiment, we need to measure spring extension. You can see on the spring balance we have a scale, which measures the extension of the spring in millimetres. We see that we have zero extension of the spring, as shown on the scale, when zero force is applied to the end of the spring balance. In order to establish the relationship between force and spring extension, we will plot these on a graph. The vertical axis will be the applied force F in newtons, and the horizontal axis the spring extension X in millimetres. The first point for us to plot on the graph is zero extension for zero applied force. If we now apply a force of 5 newtons to the spring balance by adding this mass, which is a weight of 5 newtons, we see that the spring extends by 50 millimetres. When the mass comes to rest, the applied force, which is the gravity force of 5 newtons vertically down, is being balanced by the restoring force of the spring, which is 5 newtons vertically up. So let's plot this point. That is 50 millimetres extension for an applied force of 5 newtons. Now let's add another 5 newtons to the spring. Can you guess how much it will extend? As you can see, it has extended another 50 millimetres, so that the total extension is 100 millimetres for a total force of 10 newtons applied to the spring. So let's also plot this point. Now you can see that the 3 points lie on a straight line. This is very important, as it is the principle on which the spring balance works. It simply says that the relationship between force and extension is linear,